All right, welcome back. We're going to create a rock, paper, scissors game today. And to start for this lesson, we're going to list out the pseudocode and some of the game logic for the game. So I'm assuming that a lot of you have already played rock, paper, scissors. It's a pretty common game that happens in people's childhoods. There's even other elements of this game, like I think there's like rock, paper, scissors, Spock, lizard, volcano or something. There's nuclear bombs. There's different variations of this game, but we're going to work just with the rock, paper, scissors element. So first I've opened up a new .py file in my solution here for the Python course, and I called it RPS underscore and my name. I'm going to start off the same way that I always start off. You're going to put in your initials. Here we go. I'm going to put it in comments, my initials, and the dates. And this is going to be rock, paper, scissors. Classic. All right. So to start off, let's think about how rock, paper, scissors is played. Typically, there's a roll. We already kind of went over this with Visual Studio. We did a little bit of a diagram of it, so I'm going to open that up just so, or with Visio, sorry. I'm going to open that project just so you can see it, so you can see that we've diagrammed the logic for this already. Yes.
Why is there a Minecraft education
I couldn't tell you. I couldn't tell you. All right, well, let's talk about this. I'm just going to pseudocode it out from right here. So to begin with, we have begin game. We're also going to have our initial variables. So let's list out everything that's going to happen here. We have our initialized variables. We're going to have our defined functions. And then we're going to have the game, or what is typically known as the main function. This is usually how most programs are laid out. You have an initialization of variables. You have any functions that you're declaring. You usually also import libraries up here. So this is typically what happens at the beginning of any kind of code. Some types of code are a little bit different, like they might be just definitions that you import into something else and use as the library. But most code works like this. You import your libraries, you initialize your variables or your global variables, and then you have any functions that you're going to define that are just local to this particular file, and then you have the main section. So under the main section, we're going to have begin game loop. So the game is going to just be a while loop. We'll say while game running. We did this before. And I'm going to make a variable called game running. And I'm going to set it to true. All right, so what that means is right now, there's going to be a game running. And while that game is running, it's going to be running this loop. So what I'm going to do is I'm going to type this a little bit differently than you're used to in previous lessons. I'm going to define a function for each thing I need to do, and then I'm going to call it down here in the game loop. So it's going to look a little bit different than we did in the past where we hard-coded everything, but most of the time you don't hard-code. Let me see if I can find the quintessential hard-coding image. Why you don't typically hard-code. Let me see here. So here it is. If you were to hard code, technically it would work. Whatever function you have would technically work, but it doesn't allow for a whole lot of options, so to speak. So when you hard code things, this is kind of what you're making. You're making something that will work in a very specific instance. If you sleep just like this, your code will work great. But if there's any kind of changes in your code, then it might not work just great. So this is why we tend to create functions to allow our codes to be a little bit more forgiving when there's changes in it. So, what's that? Cursed picture. All right, so In this case, we want to create functions for each thing that's going to happen. But let's list out what typically happens in a game of rock, paper, scissors. When you first start, usually each player chooses what their attack is. So player 1 attack, or we'll say player 1 attack, and player 2 attack is chosen. Right? So they choose. And then you're going to have some kind of a comparison between those two things. So we'll compare attacks. And then we got to list out what the possibilities are. There are different ways that you could potentially code this, depending on how you're looking at this logistically. But for this game logic, I'm just going to code out what are the possible things that can happen. You can have player 1 rock, player 2 rock, or we'll say scissors. Then we have player 1 rock, player 2 paper. Then we have player 1 scissors, player 2 paper. We have player 1 scissors, player 2 rock. We have player 1, whoops. We have player 1 paper, player 2 rock. We have player 1 paper, player 2 scissors, and then we have player 1 equals player 2. And that would be if player 1 chose rock and player 2 chose rock. If player 1 chose scissors, player 2 chose scissors. Player 1 chose paper, and player 2 chose paper. So that would be this last statement right here. So we'll call this the default statement. And each one of these would be a different case. So this is case 1. This is case 2. This is case 3, and so on. If I were smarter, I would copy this and paste it right here so I don't have to type as much. There we go. So these are our possible things that can happen in rock, paper, scissors. And we could also list out what would happen. So right here with player 1 is rock and player 2 is scissors, rock beats scissors, so player 1 wins. We want to list out what would happen for each one of these scenarios. Player 1 rock, player 2 is paper. That would mean that player 2 wins. And we're just going to keep on doing this. We're going to list out all the possible scenarios. Scissors versus paper, player 1 would win. Case 4, we have player scissors versus rock. Rock would win, so player 2 wins. Paper versus rock. Paper would win. And paper versus scissors. Scissors would win. So there we go. Here are our possible cases that we have here. Then we would want some kind of scoring mechanism. So we want scores to be calculated and displayed. And there we go. It would keep on going. You can make it to where it's the first to a certain number. So you could put like a score limit reached. And then you could have a message to ask if you want to play again. Replay message prompt. There we go. That looks pretty good. As far as the game, this is generally what happens in rock, paper, scissors. Player 1 and player 2 would both choose what they are going to do. You would compare the attacks, and these are the different possible scoring mechanisms that would happen. Then you would calculate the score that happens. If player 1 wins, you'd add to their score variable. You display what both of these scores are. And if you set it to be, all right, it's first to a number, like first to 5 or first to 10 or whatever, You could have a score limit to where each player could play to a certain score. And lastly, when you reach that score, you would declare a winner, and you could have a replay message if you wanted to play again, or you could quit. Or quit here. And I'll put also down here, I'll put declare winner message. All right, so this could be the pseudocode for our rock, paper, scissors. The game logic is already included right here with your case statements here. I'm not going to actually code this out. That's your job. I'm trying to arm you with the ability to code on your own. But this is what you need. This is basically how rock, paper, scissors works. If you need this code, I'll put it on our OneNote class notebooks. That way you can easily get to it. And of course, it's live streamed right now, so you can see how I came up with it. But really, I didn't do any coding. I just kind of listed out what the logic was. I hope this was helpful. Have fun coding.